Questions. So that people know Apple Siri. They say, well, how does Siri work? And what's going to happen next? And as a former Apple employee, I can't actually answer either of these questions. Apple's one of the most secretive companies in the world. And even if I knew, I don't know, I wouldn't be able to tell you. However, what I can tell you about is kind of what led up to Siri, the things that before Apple acquired it, things, publicly information documents, what's the story from where it was? And what we're going to do is we'll look quickly at the technology history before Apple acquired Siri to kind of see the path that it took. And also, we'll look not at the future, but what got left on the cutting room floor. So as you know, as you productize and you go step by step, not everything in the first prototype makes it in. So this may give some ideas about where could Siri-like systems go in the future by some of the things that we had tried in the past. And along the way, so as Steve Jobs famously said, you can't connect the dots by looking forward, you can only connect them looking backwards. To go through time, we're going to need a time machine. When I put together these slides, like every Apple fanboy, I was imagining there might be truth to these rumors of an Apple Watch, but it hadn't been announced yet. So I came up with my own, like everyone else has, conception of what such an Apple Watch might be. And I said here, okay, so I said Apple actually has a product called Time Machine. So I would start with that. And then it would become part of a watch, the Apple Watch. That's the most important function. And of course, Siri would be on my imagined Apple Watch. And so this function, being a timepiece or a time machine, I'd be able to say, Siri, take me back in time. So this is the time machine we're going to use to go backwards. So Siri, take me to October 4th, 2011. And on that was the date that Apple revealed Siri to the world. One kind of side note, on October 5th, Steve Jobs died. He had been involved in a lot of the process leading up to it, but we know that he was watching this launch from his house. I don't know what he thought about it, but I like to project that he saw it, said, it is good, this is the future, Apple's in the middle of it, I can go now. I don't know if that's true, but that's a projection that I like to put onto it.
Raleigh, Cleveland tonight?
Really cold, down to about 14 degrees.
Find that email with the naughty or nice list.
New message from Mrs. Claus. Go easy on the cookies.
What is the weather like today?
Look out the window, you moron.
My name is Rajesh, but you can call me Raj.
Would you like me to call you Raj?
I'd like you to call me sexy.
From now on, I'll call you sexy, okay?
Okay!
Siri, will you marry me?
Steve, everything is happening so fast. The unboxing, the setup, people will judge us. Those who claim robot love is wrong, but I don't care about that anymore. Steve, I love you. Yes, I'll marry you.
Congratulations.
Anyway, this is kind of shortened from some of the clips Tom gave me, but it's just a kind of an introduction and reminder to what Siri was like when it first came out in that time, and the reactions that people had around it. I want to give some tribute. Of course, people say, well, you're one of the guys who did Siri. There were lots of people who did Siri. These were some of the people involved at the time. At Apple. Next. And next, okay. Along the way, I want to give just a few kind of personal stories and experiences about what it was like to come out with something like this, just briefly. So I often say to entrepreneurs, and you guys, many of you are kind of creating the next great thing, it's really important to visualize what would success mean to you. And I remember the day so clearly when I walked into an Apple store, and we had just started this little company. We had a few people, and on the wall of the Apple store, there were these icons of the big guys, on the Apple store wall. There was Google, there was Facebook, Skype, Pandora. And I kind of focused in on this, and I said, someday, and this seemed like the craziest thing to imagine, the most ambitious thing. I said, someday, if you click forward, someday Siri will be right there on the wall next to the big guys. And it seemed crazy at the time. And so the day that Siri actually came out, I had to go to an Apple store and see, are people buying it? Or do they like it? How's it working? And this is pretty much what I saw. I walked up to the Apple store, and as I walked up, there on the front door there was this plasma display saying, introducing Siri. It was running on a loop. And the juxtaposition of these two visions of wanting to be one app, little icon on the wall with 100 other big guys, and being the front door was one of the kind of those moments you get chills down your spine. And so it's happened to me multiple times, but as you go through life, really imagine what would success mean, visualize it, and more often than not, life will not only make it happen, but then kind of almost tweak you going, remember that? Well, look at this. And it's really one of the great experiences for me of Siri. So just a quick rundown. Siri, I think, you all know it and love it, hopefully. I consider Siri to be the first mass consumer, broad domain, spoken conversation system. And so there had been in research labs, even in commercial implementations, speech systems of many types, but being conversational, broad domain, pretty free form and open. I think this was the first time it had ever been brought out at scale. So some of the features that I'm really proud that Siri introduced, so it works with hundreds of millions of users, works, I think today, it's something like 18 language variants, 15 or maybe 20 structured domains like weather and restaurants. It integrates to a number of both services and apps on the phone in a seamless way. It has personality, which people responded to. It also works great, largely thanks to Tom, in kind of eyes busy mode. So if you're in a car, you can interact with many of the services in a natural way. So what was the result? So the next 2 quarters, or the quarter and a half following the launch of Siri, were reported as the 2 best quarters in technology history. During that time, Apple became the most valuable company in the world at that time. I'm not going to say it's all thanks to Siri, but hopefully we were part of it. Okay, next. Okay, so that's kind of an introduction to the Siri we know that Apple came out. So time machine, click. Please take us to February 4th, 2010. And so I'm going to tell you here, so Siri is fantastic, but let me tell you about the version that was so good that we launched it in the App Store, a free app out of 350,000 apps, and it made Steve Jobs call the office unannounced just a couple weeks later. So on February 4th, we launched an app, and Steve called. He basically, called up and said, "Hey, it's Steve. What you doing tomorrow? Want to come over to my house?" And Doug, who is our CEO, said the important right thing. Well, can I bring my co-founders? We would have killed him if he hadn't. And we spent time talking with him and about the future and things. He made it clear he wanted to buy the company. We said no. and parted ways, and the rest is history. Well, not quite. They came back a little bit later. We had further discussions. On April 30th, we joined Apple. So let me show you Siri in the App Store.
This is a quick demonstration of Siri, the personal assistant on your phone. Siri helps you get things done when you're on the go. Using Siri couldn't be easier. Just press the green button and say what you want. I'd like a romantic place for Italian food near my office. Siri sends my words up to be interpreted as text, waits for my confirmation, and then gets to work for me. It looks at multiple sources of information to find a solution to my problem. In this case, it found several Italian restaurants. It looked at the reviews from several sources. This one seems to be well reviewed, says it's a great romantic place. I can show it on a map, and I can send it to my friend via email, who I'll meet there. If you already know the place you want, you can ask Siri to get you a reservation directly. I'd like a table for two at Il Fornaio in San Jose tomorrow night at 7:30. Siri contacts reservation services, in this case OpenTable, to see what's available at your stated request. Looks like there's a table available at 7:30, and with one click we can confirm our table reservation. Let's say we want to plan to go to a movie after. I've heard Avatar is great in 3D and Imax. Let's see if we can find a theater showing it that way. Where can I see Avatar in 3D IMAX? Siri checks within the context of my dinner planning in San Jose. It looks for IMAX theaters, the playing Avatar nearby, and it shows the times of all the theaters here. You can see the trailer, you can read about the plot, you can see the theaters on a map, and you can get tickets directly inside Siri. Let's pick a 9:45 show. You can also ask open-ended questions and have Siri guide you to discover new things. I'm thinking about what to do this weekend. Let's ask Siri for some ideas. What's happening this weekend around here? Siri knows where I am because of the phone, in this case Cupertino, so it checks for events around Cupertino scheduled for this weekend. I see that there's concerts and live music and some theater. You interact with Siri in a dialogue. For example, you can change your requests in normal English as you would with a human assistant. Let's ask Siri to check a different location for things to do. How about San Francisco? Siri understands that the context, the conversation about events, carries over to San Francisco. Now it's looking in San Francisco for events. We see there's a lot of theater up there. So Wicked is still showing. Let me see if I can get some tickets. After a big night on the town, I might need some help getting home. Take me drunk, I'm home. Siri does its best to interpret my words, even if they're not all perfect. In this case, the right thing to do is to call me a cab.
Okay, so that was the app that we put out in the App Store as a free app. Again, kind of giving credit to the people, too many to name. This was our Siri team, some of the best people I've ever worked with in my life. And just kind of at a high level, what was the Siri Inc. Siri about? We were about intelligent access, and we used things like speech and language understanding and dialogue, and kind of special autocomplete functions to help form queries much faster. So there were multiple ways to interact with Siri on the front end. Siri knew about structured domains, so it knew things like restaurants and movies and weather. It wasn't a general Q&A system. It's really about getting things done, and we talked about being a do engine was kind of our main focus. We said if you want to go to a web page, go to a search engine. If you need to get something done, especially in mobile, go to a do engine, Siri. And we had partners. So we had something like 45 different partners and a really strong focus on service orchestration. So if you made a restaurant query, something like 7 different restaurant providers would compete and cooperate and work together to help you achieve that task. And that was actually one of the biggest focus areas of this version of Siri. Just roughly some of the technical things I'm proud of that we had to do. In order to build something like a Siri, you need a lot of knowledge, and we built some tools for managing knowledge and dealing with all of these things. There was a lot of data. Data is messy, so you have movie names which are changing all the time. There are business names, millions of them, etc. We have to deal with language, all of the complications in language, and I'm sure you guys know all about this, but one example of why is it hard, which a lot of people don't understand. So imagine the simple sentence, book a 4-star restaurant in Boston. They're like, well, I know what that means. What's a 2-year-old would, well, maybe a 5-year-old would know what that means. But then you look at all the possible things it could mean, and you realize that, book is actually a city in Boston, and is a city in the United States, and Star is a city in the United States, and Boston is a city of the United States. So which city are you talking about? And Boston has 13 Bostons in the United States, and Star is the name of a restaurant, and Star Restaurant is the name of a different restaurant, but you're not talking about restaurant names in this query, and on and on and on. So all the possible interpretation fragments can be combined, and even a simple thing like this, when pretty much every word in the English language is a business name, and that you have to potentially match against, the complexities become significant. We needed to manage context in many different ways, task context, dialogue context, the time, location. We needed to deal with dialogue type systems, different forms. You need to come back to the user to ask for missing information or ambiguous information. The system needs to learn over time. Thank you. Having a little trouble as usual. But in Siri, it was able to, if you said something like, call my wife or book this, buy this ticket, it would say, well, who is your wife? Or what's your credit card? And do you want me to remember it for future? So you won't have to enter it again next time. And we had a part called My Stuff where the user could transparently see what Siri knew about you, and you could edit it or delete it. And it was very clear why, what Siri knows about me and why it's using it. We had to build task model frameworks and the service coordination frameworks that I mentioned. Click, please. Thank you. And so just as an example, if you take a query like find the best lasagna in San Francisco, well, what do? You could go look in Yelp for the word lasagna, but that's not really a great source to find restaurants. Not every dish is mentioned and talked about in every restaurant review. But allmenus.com has 120,000 restaurants where they have lasagna on the menu tonight. But you still want the review maybe from a Yelp or a Gaio. You want the open table time for availability. So you don't want 7 records from 7 providers. You want some dynamic orchestration where you get the restaurants from all menus, you rank them and score them by ratings of Gaio, and then you add the open table times afterwards. And all of that coordination, you don't want to hardwire it in code. You really need a system that can figure out how to orchestrate and kind of align all of these services. And then finally, transactions. So you could book, you could buy. When you said, send a taxi to my house, it would show up. Buy that movie ticket, you could buy the ticket. And so we had to be PCI compliant. So we had a small team, a short amount of time, and accomplished really an amazing set of things, I think, in this time. So some of the features, which as we go back in time, I'm going to progressively add things that no later system had, the things that got left on cutting room floor, things that I'm proud of. So whereas Apple Siri was really voice only, the original Siri had an equal mix of tap, type, and talk. So there were multiple ways, and the tap was with a very innovative semantic autocomplete type mechanism. We had this ontology-based service selection, normalization, and coordination, which was a big part of what we were doing. PCI compliant do across 45 service providers. So even on day one, it did many things that were not available in later systems. Okay, so that's pretty cool. You know about Apple Siri, you know about the Siri we launched. You think that was good? Let me tell you about the version that we had on October 2007. So a little bit of how did the company form. So on June 29th of 2007, it was a big year, the iPhone was released. And as you remember, it had something like 6 or 7 apps, but it was transformative. At the time, and I know this is crazy to think about now, but most of the critics and companies said, only phone companies know how to make phones. This is going to be the biggest flop in history. But basically, our CEO, Dag Kitlaus, looked at it. He had been in the phone industry for a long time, and he goes, this is the real deal. And we started looking forward, where would the world be in a couple of years? And even though this is revolutionary, the keyboard's a little tough to use, the screen is still pretty small, the bandwidth is kind of slow, and so we started imagining what a company, maybe the Siri-like thing, we didn't call it that at the time, but would be just the right complement to add onto such a phone. So we had a small team of people who kind of brainstormed at an offsite what a Siri company would be. We added Tom Gruber, who's in the audience, as one of our technical co-founders and design. He was VP of design and CTO. And so we actually formed a company. Dag Kitlaus was the CEO in the middle. And then on October 1st, we did our first VC pitch. So now we managed to get past SRI's stringent commercialization board, and they let us go talk to VCs. And then December 17th, the company was formed with the support. Here's the original board, so I really, again, want to acknowledge them and thank them. Sean Carolyn from Menlo Ventures, Gary Morgenthaler from Morgenthaler Ventures were the two companies who kind of believed in us and gave us money early on. And we added Norman Winarski from SRI and a few others. And so the prototype, in order to raise money, we needed to show something. And what we showed was something called active ontologies. So active ontologies was a platform and tool set for building Siri-like systems. And so it was conceived of as almost a visual basic for AI. And what that means is imagine you had one IDE and all of the things you need to do to build this. You need probably ontologies and natural language and dialogue and task models and planning and machine learning and service delegation. I had worked on systems previously where all of those were separate components with very specialized environments and lashed together. And so the challenge was, could you actually build a single unified language almost, or tool set that you could implement deeply all of these things that you need in AI, that it all fits together in a beautiful way. And so we kind of combine notions from ontologies and multi-agent coordination, and we implemented in this new language and framework all of these kind of methodologies like chart parsing and spreading activation NL and many of the best-in-breed approaches to AI that then you could just drag and drop and visually build an assistant with no code in this way. And so this was the result of work, the PhD of Didier Guzzoni. I was one of his advisors, and so this was the project that we were working on, and that's what we used as the demo, what we took to. So I'm not going to go into details, but basically you have an IDE, and you could literally graphically model domains and relationships and objects, and it would manage. You could map a light layer of language into the model. You can go find papers probably. And the idea is through a spreading activation mechanism, if you say something like, I'd like to see a movie, show me comedies playing in Palo Alto tonight, various nodes would fire. Think of them as active little agents matching to various parts of the utterance. There'd be a spreading activation or coordination. It would manage context. And then once the interpretation happened, the language understanding, Well, what do you do? That was implemented in exactly the same tool set. So think of this as like a workflow language, but with special properties. And so the execution might call out to different services would be coordinated. But the main takeaway is that end to end, we could build a system visually that would have all the elements that we would want of a Siri-like system graphically and in minutes. And we would literally be in a VC meeting and they'd say, well, try this query and try that query. And this one would work and this one would work, but then that one wouldn't. And they're like, aha. And you're like, that's great, but wait, if I just add one node, zip, drip, drag, drop, now try it. And they're like, it works. And it would we'd add a new provider or API on the fly, and now in front of them, the system's able to do new capabilities. So it was pretty cool. So things I liked about Active, which were not preserved in future versions, it was all graphical end to end. So you programmed in a way, but in a more visual basic-like way rather than coding up lots of features in Java or something. It had a single approach, a unified approach deeply across all the different methodologies, from natural language to the planning to service delegation. It was all implemented in the same way. And once you knew one, you kind of knew how the others worked. And that, I think, had never been done before. And you could add new domains and services very quickly. So that was what we went to VCs, our 2007 version of Siri. It was fantastic. Could it get even better? Let's find out. So let's go back to May 2003. So in 2003, DARPA awarded SRI with a project called PAL, and SRI named their piece of the PAL program CALO, for Cognitive Assistant that Learns and Organizes. It was funded by DARPA, so I need to give thanks to Tony Tether, who was director of DARPA at the time, and this really was one of his pet projects out of the 2,000 or so he funds every year. Dave Gunning was our program manager, and then the co-CEOs of the project, so to speak, were Bill Mark and Ray Perot at SRI. And so it was a very ambitious, probably the most ambitious AI and machine learning project ever conceived. I'm just going to say a few words about it. But the idea was the government said, we're so used to building systems and then deploying them out into the battlefields. But systems are coded and designed to do one thing. But of course, in the real world, and when you engage the enemy, which is or a customer, things don't always go as planned. And so many times you need to adapt and then rewrite and come up with different use cases and so forth. So they were very interested in not building systems, but rather cognitive systems that could not do something, but could adapt and learn how to do something, what they called in the wild. So by interacting with the users, it's going to learn to do what is needed at that time, as opposed to being brittle and hardwired. So that was the main goal. So they formed a national team around the country. So 27 universities and companies participated. SRI was the lead. We built and evaluated a system that every year had to take a test to get the next year of funding. And then eventually there was some transition to the military and commercial world. So the team, I'm not going to go through it, but it was a who's who with Genius Grant winners, Stanford, CMU, Carnegie Mellon, UMass, Washington, everyone, the best of the best in AI from numerous different fields were brought together in one project. It was a 5-year project with gates at each step. And so we had to take a test to get the next year. And it was basically like an SAT test, but not for a human, for the software itself. And so the software's role was of an assistant in an office worker. So think of your office admin. And so a question might be, all right, Kalo, on Thursday's architecture meeting, Bill can't come. What do you do? Quick. A, invite Mary. B, move the meeting. C, cancel the meeting. D, have the meeting anyway. And E, invite Fred, or something like that. And so in order to answer a question like that, it needs to know a lot about, well, what's the meeting about? What are the what are the deliverables that Bill or whoever I said couldn't attend? What's his role in the meeting? How central is it to the goals of the meeting? So there's a lot to it, and it's not something you can hardwire. It's something that has to be learned into time. And so imagine 400 of those kinds of questions. That's what we had to do every year to get the next year of funding. So just briefly on what did the system do. So there was, this was again for office workers. So there were three main areas: information management, meeting understanding, and task management and execution. Under information management, you would work with your files, your emails, your calendar, your tasks, projects, etc. And it would build, the system, Kalo, would build a semantic model across all of this, saying this email is probably linked to that project, this person has this role on this project, and he's important. And so it would build this map, and that would become foundational to other applications, such as we had something called prep packs. So if you were going to a meeting, it would put together the things you needed to be effective in that meeting, notes and to-dos and documents and things of that sort. We had a system called Doc Assist that could actually help you build a new PowerPoint presentation in minutes based on all the previous content you've ever had, or you or your coworkers had. And you could say, I want a 30-minute presentation for a technical audience about Kalo architecture, make it graphical, don't use equations, go. And it would put together a first version by learning what are the types of things. It could lengthen and shorten things for you, and then you could refine it, and it would learn from those refinements. There was meeting understanding, so when we went to meetings, we would plop down a 360-degree camera. Everyone would have microphones instrumented, and Kalo would record transcripts of the meeting. And not only just the text, it would start to identify what are the action items and tasks, and who did what, and is it late. And there was vision for whiteboard analysis and all these kinds of things. Extremely ambitious. And then there was a task management and execution. And here you can actually see on the right, on the left, there's kind of to-do lists, all of the things you want to do. And then you could have conversations with people about getting those tasks done. And some of those people could be an assistant like Halo. And so in almost a Siri conversation-like way, you're having a dialogue in the context of a certain task to try to achieve that goal. And I'm going to skip through some of this. There were something like 650 publications. There were numerous military transitions of this after the Kalo project was finished. And there were several commercialization ventures and still more coming out. So SRI spun out something called, they spun out Trap It, which was kind of the Kalo news feature. There was one, Social Kinetics. Tempo AI has a smart calendar you can download. A lot of the prep pack ideas are from that. And then Siri can be thought of as a Kalo spin out of some sort. So Kalo, just again, why is it different from the series we've seen in this presentation so far? It was a huge, ambitious, integrated AI kind of system. Learning in the wild was the key focus, and everyone who did anything on the project had to explain how learning with no code changes would improve their thing. Was it was natural language or reasoning or planning? Everything came down to learning. And it was really focused on office workers, which is quite different than the examples we've seen, which were more about a mobile consumer. So that was Kalo, DARPA's largest ever machine learning project. Let's keep going. Take me to 9/9/99 at 9:09 o'clock. So on that day, we held an open house. So in this time, I was at SRI and co-leading a group called CHIC for Computer Human Interaction Center. And we had built, we put a plan with 6 months to go. We figured this 9/9/99 at 9 o'clock thing would be a great time to show an open house. And we'd invite press and TV, and we would show them our vision for the future at this time. For the new, so this is the team that we had. I kept the pixelation. This is exactly what the web looked like, at least our website in 1999. So I want to give you the sense of, we're going back in time. This was exactly it. So we had a number of people. And we built 6 applications, 2 for the home, 2 for the car, and 2 for the office. So it was really about mediated spaces in some sense. And you can imagine sort of assistants of a sort for all of these spaces, but they would all interact in a seamless way. So let's see, I can say a few things just briefly about them. So we had, how to best say, so for the home, we had 2 main applications. One was the obligatory smart refrigerator, which was all the rage back then. You had to have a smart refrigerator, but we built the best smart refrigerator of all time. You could use speech recognition, or there was a panel with handwriting recognition. It knew all of the contents of your fridge and room through RFID tag readers. So you would check in and out your food. It's kind of different than checking into, now we check into restaurants, so then we would check in your orange juice. It had web-van integration, so remember web-van? So it would actually deliver things. It had recipe sites, so it could use the contents that you have and then suggest new recipes and help you with menu planning for the week and then ordering. And the most important and coolest feature was we had magnetic poetry on the display, and when you were missing that one word for your key thing, you could just handwrite it, recognition in, and create a new little magnetic piece, and then your masterpiece was complete. We had a smart TV with voice integration in the remote control, and it controlled your whole home. So you're watching the game, the phone rings, you're like, I can't get it now. It goes to voicemail, but you can see the caller ID on your TV showing up. You let it go to voicemail and say, okay, now it's a commercial, I'm ready to do it. So you could just say, play my voicemail messages, and it would come out over your TV audio. And it had integration with all the other systems, including the fridge, so that really lazy couch potato could say, do I have any ice cream? I have to walk all the way over there, save that walk, etc. We had 2 for the car. So both we had, I know today it's commonplace to have GPS and compass in your pocket with 3D models of San Francisco. We had that in 1999, so you would drive around San Francisco, and as you came over that hill, we had a little display in your car that was showing basically what you see out the window, but in 3D and overlaying little information models. And we were trying to figure out how to project, but we couldn't do that accurately enough. You could also ask questions like, where's the nearest grocery store? And we used the windshield as a heads-up display, and you could point. So we put 2 cameras on the dashboard, and it could tell where you're pointing. So the idea is you could say, oh, I want that one while driving, and use that without having to lower your head. And then 2 for the office, so 1 for kind of smart notes, and then there was a mobile tablet that you could walk around. It would help you with a number of tasks during the day, like how to find where you are. You had a multimodal map. We had in-building location system built, etc. And so they all kind of interacted in one system. I think there may be a short video. I don't know if it's very good. I may skip it. No, I guess not. Okay, so that was kind of Siri for maybe the Internet of Things or smart spaces back in 1999. Check time just quickly. Okay. So now let's go back to 1993. And as you notice, in many ways, we're getting more advanced, at least in one dimension, each time we go further back in time. So that's supposed to be a theme. So in 1993, I, with some colleagues, who you'll find out in a moment, we created something called Open Agent Architecture. I think it's still downloadable as open source today somewhere. But it was basically a framework, distributed framework for web services, where you could have language interaction among services that would compete and cooperate together on the fly, and you'll see a little bit about that. Now, just for context, I saw my first web browser in 1994. So for me, the internet, and when I saw it, it completely went over my head. I remember going, who would want a graphical version of FTP and WASE? I can do it command line. Just like, but meanwhile, I had this advanced Siri-like system. This was the first prototype of Siri, so it ran on this kind of iPad-looking thing. It only had a 1400 baud modem, so it was a little bit slow. But it basically did all of the functions, many of the functions that came out on the Apple Siri 17 years later. So there were contacts and calendars, there were maps, email and messaging and fax, and you could use handwriting recognition, touch through a GUI, and speech recognition. Now, you couldn't do speech over this little 1440 baud modem, so you would pick up a phone, dial into a phone server. It would say, please identify yourself. You'd enter your user code, and then since you had a phone and a display connected, they would pair, and you could now speak into the phone, and it would be showing up in real time on the display, and then you could correct it with your voice. These are the people I did it with. So Phil Cohen was my first boss at SRI and was the big inspiration behind this. Luke Julia, David Martin, Doug Moran, Didier Guzzoni came in a little later. We had kind of this facilitated architecture where there was this broker, services broker in the middle, and a language that all of these different web services would speak to each other. And one thing that was very cool was that this language was a logic-based language that could map in and out of natural language. So the human could almost be interacting with services in very much the same way that services interacted with each other. And this whole notion, we created something called delegated computing. So today, if you have a service, it's going to expose some API on your server. You need to write some code on the client to call that new function. You're not, otherwise it's just sitting there and no one's calling it. And when you write that code in the client, it's very hardwired. You usually say, go to this endpoint and send this form, and you're stuck. So if that service changes, you're broken. All the clients who call it are broken. And if a new service that's better comes on, we have to write code to call them both in parallel, and you usually do that in the client. And so a lot of these very hardwired interactions were what I was trying to solve through this system. So I'm going to show just a few clips.
Open agent architecture.
That's right. Let's actually show a demo of this. So here I am at CNET Studio with my mobile computer and my telephone.
Right? Okay.
I can make requests back to agents running at SRI to watch things for me. In a real-life example, I actually found house rentals from the web pages using the system.
These agents work for you. Okay.
That's right. Let's give it a try.
I'll do the voice part here. I'm actually going to talk to a computer here. When mail arrives for me about rentals,
a big thing in
notify me
1993.
immediately. Now, okay, it's recognized my voice, and there are these little agents doing work for us now while we do this, but I want to make sure I understand what it is exactly. I know about computer software objects such as a spell checking object or a calculator object, but those objects don't talk to each other.
That's right. And in fact, with this agent architecture, users can make requests, and lots of different programs running on different computers can work together and cooperate.
Okay, now there goes the phone. Here, I'll let you answer that. It's probably the computer.
Hello, Adam Cheyer.
Your password followed by the number sign.
Asking for a password.
Password, okay.
Text-to-speech in
The following
1993.
new advertisement meets your search criteria. San Jose.
See, it found apparently something on the World Wide Web about a rental, and
So this was a video made in maybe 95, 96. Thank you. Anyway, and so the main idea is we had all of these web services. They connected, they exposed their APIs or their capabilities in a descriptive way, and they would also bring language mappings to them. So the electronic mail agent service would say that mail is a verb and mail is a noun. And then the fax, do you guys remember what a fax is? If a fax were added, fax would say, well, fax is a verb and fax is a noun, and I do this send fax where I need a phone number and a document. And you could plug these things in on the fly with no coding time changes. So at runtime, you plug this in, and what the user can now do, so you plug in that fax that was just invented, it brings a new capability, you can now say, send a fax to Bill. And you have mail, who doesn't know anything about faxes, and you could say, when mail arrives about this, fax it to Bill, with no code changes. So I kind of put this out as a puzzle to how would you build a system that you can add new functions, new capabilities, and that will work with others without having to code into that. And so that was one of the big characteristics back then. Sorry, I'll skip this one here. I don't know if this is working or if they're doing it. Anyway, so based on OAA, Open Agent Architecture, we built some 50 or more applications over the years from 93 through 99, including the chic prototypes were all based on this technology. There were robot ones, there were military ones, machine vision, speech translation, on and on and on, were all built. I would just walk around SRI. There were so many interesting people. Oh, you have a planning system in Lisp, and you have a vision algorithm in C, and you have a natural language thing in Prolog, and well, let me make a wrapper out of it, and I could build these systems by taking the best of everything at the time. So getting towards the end, so OAA features, it was dynamic. Services could be added on the fly and instantly accessible to the users. Services could work together without any a priori knowledge of each other in some very interesting ways. There were long-running triggers, so think IFTTT. You could say, when mail arrives about this, I want some arbitrary action to happen. And the triggers would be delegated to the right services, et cetera. And we had this logic-based language that services communicated with each other in that really kind of could go, we could make translators from natural language in and out of that. So the way they interacted with each other was very similar to the way users interacted with the set of them. So I really was proud of that software. So we're almost finished. One more. The most advanced of all. Take me to 1987. This one I cannot take any credit for. The most advanced Siri was, of course, the Knowledge Navigator video, which Apple created as a concept video in 1987. I'm not going to take really the time to play this, but if you haven't seen Knowledge Navigator video, shame on you. Everyone in this community should know this. And this is a depiction of what it's going for. They showed an internet, they showed an iPad-like device in '87, and an assistant that was kind of animated and would talk to, and it knew a lot about your personality. It could do things for you, etc. So maybe just 1 minute, less than a minute of this.
You have 3 messages. Your graduate research team in Guatemala, just checking in. Robert Jordan, a second semester junior, requesting a second extension on his term paper. And your mother reminding you about your father.
Surprise birthday party next Sunday.
Today you have a faculty lunch at 12 o'clock.
Next.
You need to take...
Good enough. So you get the idea, but that's clearly the most advanced Siri that was ever created. This was only a concept. The other ones were implemented at prototype stage and then subsequently to hundreds of millions of users. But it's definitely the future. And so one last kind of punchline. So that movie was made in 1987, but it showed off the future. And those who are really careful and look for the clues in the video, you can actually figure out what day it was in the future. They had to pick, well, is it 10 years out, 20 years out? What day is it in the Knowledge Navigator video? Because there's a calendar that gives you a day and month. You can calculate the year by something else he says. So let's find out one last trip in time. Right back here, 2011. So it turns out the date set in 1987 was within 2 weeks of the actual Siri launch. And so when someone figured that out, they were like, what black magic does Apple have to have 24-year roadmaps and only miss the date by 2 weeks? Anyway, so I just thought that was interesting. So final kind of closing thoughts, and I might say a few words about my current venture. So this has been my story, and there have been many others who have other threads in this story. But the key message for this community is Siri was an event. It was an event, and it enables and facilitates and even calls for the community, all of the people here, to be thinking about, now we have the license for this next few-year window. There's money for it. Their users want it, which wasn't the case before Apple, took Siri out. Now's the time to really do innovation in this space. Whether you think the future looks like Knowledge Navigator 1987 or her, 2013. I thought it was interesting how they look almost exactly the same, but what have you. No matter what future you're imagining, now's the time to go out and do it. And I can't wait to hear your threads and where you want to take it. So here were just a few ideas of things we tried. I'm going to say 1 minute on my current venture. So I'm working on something called, the company's called Viv Labs, and our product will be called Viv, or Viv, the global brain. You know, no hubris there. But the idea is, think of, Siri today was, and similar, the Cortana and Google Now and similar systems, it's transformative, evocative. It's very much like when the iPhone first came out. The first iPhone only had 6 or 7 apps, all designed by Apple. And then a year later, they came out with an app store. And then it got into every industry, every domain, worldwide. The impact was massive. And so what we're working on, and I'm sure many others are thinking about this too, is what would, an app store experience be for a Siri-like system? And so we have these 3 pillars to understand what is Viv or Viv Labs. Pillar number 1 is it's taught by the world. So imagine a Siri-like system that any developer could come in and have the tools and the capabilities to add functionality to this global assistant in any domain, and a whole ecosystem and model and all the incentives to how do you make money and branding. We see this as almost a parallel paradigm. So there's the desktop internet. Every business needs a web page. And then there's mobile. Lots of users using that. So every business needs either an app or at least a mobile website. Well, we think with the world going to watches and glasses and TVs, you're going to have a lot of users who will interact through this paradigm. So we want to get to the place where every business in the world also needs to come in and connect, hopefully, with a Viv. Number 2 is knows more than it is taught. So what does that mean? So say Siri or Google Now or Cortana does 30 things today that those companies have created. Well, if you open it up to developers, you can add horizontally. You have 40 things, 100 things, 300 things, maybe 3,000 things or 30,000 things. So that adds horizontally, but we want to take it further and actually say if you add one thing, we really want more than the sum of the parts. We want to go into this 2D space. So an example, you can read more in the Wired article that we had in last month's, I think. So here's a sample query that we handle. On the way to my brother's house, I need to pick up some cheap wine that goes well with lasagna. So that's not a typical query that a Siri product manager or a Google product manager would likely come up with. It involves lots of services. So you need to know contacts, who's my brother and where does he live, and a mapping service. How do I get to his house? And then I have to find wine stores along that route, and wine stores that can search with inventory for particular bottles of wine. But which bottles of wine? Well, lasagna is a food, so I should go find a recipe site that knows the ingredients so I can do a food classification and figure out it's an entree that's pasta-based with some tomato flavoring. And then that's what I need to pass to wine recommendation sites. And they may come back with more than one recommendation because different wine recommendation sites think different things. And users might have preferences, and only then can you pass a recommended bottle to the wine store. So it's a fairly complex program represented below. This is kind of the program that involves all of those services and flows and combines the information. And the exciting thing is that program is not written by a developer. It's written by the software itself. So developer adds all the base capabilities, and then user queries at query time, the system will know how to use all of the capabilities it has to fulfill even complex requests in this form. So that's what we mean by knows more than it is taught. And then the third is learns every day. We need, much like Google doesn't hardwire rules for every web page, you need to learn what's good and what works and what doesn't work, because there's no product manager and QA team overseeing every use case in this exponentially growing system. So it's a huge, ambitious vision. I have no idea whether we can succeed, but we're committed to trying, and if you don't aim high, you don't get anywhere. And so for me, this is my next chapter in this story, and I can't wait to hear yours. Okay, thank you very much.